Agtos worked together with Florida-based Ocean Machinery to develop the Ocean Blaster for blasting steel beams. It meets the requirements of the steel processing industry and combines performance and economical operation in a unique way. At 4.1 meters, the low height of the unit is especially striking. The Ocean Blaster is thus flexible enough to also be used in small production buildings. The workpieces processed in this unit can be up to 1,000 millimeters high and 500 millimeters wide. Before blasting begins, the operator uses the rotary potentiometer to set a feed rate that corresponds to the degree of cleaning required. In order to achieve a cleaning level of BSA 2.5 when using round shot as the abrasive, the feed rate is typically set at 1 meter per minute. When the operator turns on the unit, the components in the first part of the abrasive processing loop, the filter fan, the filter cleaning fan, bucket elevator 1, the lower transverse screw conveyor, and the longitudinal screw conveyor, turn on in succession. The unit is now in standby mode. The beam to be blasted is placed on the input roller conveyor, and forward motion begins with the push of a button. The workpiece activates the photoelectric sensor located in front of the entry vestibule, whereupon all turbines turn on in sequence. Following this, the second part of the abrasive process loop starts up. It includes bucket elevator 2 and the transverse screw conveyor. This keeps the abrasive in continuous circulation and available for use as needed. The entry vestibule is extremely well equipped to prevent the escape of dust. 3 separate rows of specially grouped, wear-resistant polyurethane lamellae ensure the gentle insertion of the beams. The vestibule is sealed on the top and bottom by rubber lamellae. Workpieces are transported through the unit by means of a chain-driven roller conveyor. A star disc initiator combination on the roller conveyor is used to control a shift register in the Programmable Logic Controller, PLC. This stores the corresponding signal from the entry vestibule's photoelectric sensor, making it possible to track workpieces as they advance through the unit. Once the workpiece reaches the blasting chamber, the electro-pneumatically activated abrasive feed valves above each turbine open and release the abrasive to the turbines. This starts the blasting process. This ensures energy savings and reduces wear and tear because the abrasive only impacts the workpiece surface at this precise moment instead of being released into the machine prematurely. The Agtos unit uses 4 high-performance turbines that are each rated at 7.5 kilowatts. As they move through the blast unit, the beams are blasted from above and below at staggered angles, so that beams are completely cleaned in a single pass through the unit. Agtos high-performance turbines are equipped with easy-to-exchange ejector blades. The distribution sleeve makes it easy to adjust the blast profile from outside the turbines. The turbine housing is manufactured completely of highly wear-resistant manganese steel. In addition, an anti-wear lining made of tool-grade steel protects the housing. A flange-mounted 3-phase AC motor drives the turbines. The 4 amp meters on the control panel make it possible to directly monitor the work cycles. The indicator lamps display the operationally relevant functions. The beam seen here on the output roller conveyor exhibits a blasting result that is visually and technically perfect. When a fully cleaned workpiece has left the blasting area and no further workpiece enters the blast chamber, the shift register recognizes this, closing the abrasive feed valve and shutting off the second part of the abrasive processing loop, including the turbines. If no additional workpiece triggers the entry vestibule's photoelectric sensors within a 15-minute period, the first part of the abrasive processing loop also shuts down. The unit must be restarted manually to begin another blasting run. After passing through the blasting zone, the workpieces enter a blow-off zone that is also automatically activated by the shift register. A high-pressure blower supplies 3 rows of air nozzles that are positioned to blow off any remaining abrasive on the workpiece surfaces and return it to the abrasive processing loop. Just like the entry vestibule, the exit vestibule has 3 rows of lamellae that reliably prevent the escape of stray steel shot. If they need servicing, these lamellae are easily removed as a single assembly. The blasting chamber features robust welded construction and is made of highly wear-resistant manganese steel. Easily replaceable anti-wear plates made of 8mm manganese steel and highly wear-resistant transport rollers are also located in the immediate blast zone of the turbines. The abrasive recovery hopper is located beneath the blasting chamber. The integrated screw conveyor is externally mounted on both ends. This protects the sensitive bearings from abrasive. In the blasting zone, the screw conveyor is protected from above from the impact of the blasting abrasive. The fan of the attached filter unit creates the negative pressure required to remove dust from the blasting chamber. A vertical stream of air extracts the contaminated air. The bucket elevator system was implemented in 2 sections in order to keep the height of the unit low. Section 1 contains the air classifier station used to clean the abrasive. Section 2 distributes the cleaned abrasive to the turbines. Large quantities of abrasive are transported during the blasting process. To minimize wear and tear to the bucket elevator system, the area of the buckets exposed to the direct discharge of abrasive was additionally protected with a plate made of manganese steel. The abrasive cleaning system operates on the principle of a cascaded air classifier. A self-regulating flap gate is used to create a uniform abrasive curtain across the entire width of the processing area. The contact pressure of the flap gate is set using counterweights. A stream of air generated by the filter unit's fan cleans the abrasive of dust and undersized shot. A special slider plate is used to make fine adjustments. If coarse material enters the abrasive processing loop, it's removed in the screening box. Undersized shot, that is, damaged or worn out abrasive, is collected in a container. The optimally cleaned abrasive is collected in a bunker beneath the classifier and is transported by the second bucket elevator to the individual abrasive storage containers that feed the turbines. It still remains to be seen how the dust-laden air from the blasting chamber and air classifier system is cleaned. After passing through an impact separator that protects the filter from coarse material, the air then flows into the Agtos cartridge filter. The volumetric capacity of the filter's radial fan is 4,500 cubic meters an hour. The conical shape of the 12 filter cartridges has several advantages. The flow angle of the incoming air, for example, makes better use of the filter's surface area. Dust particles also fall off the filter surface more easily at the moment a cleaning impulse is generated. The conical shape of the cartridge counteracts the downward decrease in the strength of the cleaning impulse so that the bottom end of the cartridge is also completely cleaned. The use of a safety filter attachment as a secondary filter allows the exhaust air from the filter to be returned directly to the production hall because the residual dust content is now below 1 mg per cubic meter. Differential pressure measurements are used to continuously monitor the difference in the pressure between the filter's crude and clean gas chambers, which indicates the amount of dust in the filter. The degree of dust loading is used to control an automatic cleaning system. With the clean gas chamber open, the air nozzles are easy to see. Dust falling away from the cartridge is discharged via a funnel into the collection drum below. Exchanging the filter cartridges is one of the few types of maintenance required by the Agtos unit. This maintenance work has been greatly simplified because the cartridges are easy to remove after releasing the clamping mechanism. During the exchange, the technician inserts the support cage into the new cartridge and clamps it under the air nozzle. During this process, the maintenance technician remains outside the filter unit and thus in a clean environment. Thanks to this system, which functions independently of the technician making the change, the cartridges are installed with the correct contact pressure and thus provide for a perfect seal. This prevents the cartridges from being installed incorrectly. Replenishment of the abrasive supply takes place at the practical refill station. A complete sack of abrasive is swung onto the filling funnel and the 25 kilograms of material quickly load through the protective screen. Finally, let's take a quick look at the unit's high level of manufacturing quality. All electrical cables are protected as they run from the control cabinet to the machine components in sturdy metal conduits. Only direct drive motors are used to power the turbines, screw conveyors, bucket elevators, and fans. The turbines are installed from the outside as a separate component group. As a result, all parts subject to wear and tear are directly accessible. When will you optimize your work process with an ocean blaster from Agtos?